In 1944, deep inside the Aberdeen Proving Ground in Maryland, the United States Army was testing something monstrous, a weapon so large that when it fired, the ground shook for miles around. The blast was so powerful that observers standing at what they believed was a safe distance felt the shockwave hit their chests like a punch. The crater it left in the earth was 12 meters wide and 4 meters deep. You could park a school bus inside the hole made by a single round. This weapon was called Little David. The name was a joke, a biblical reference to the small shepherd boy who killed the giant Goliath. But there was nothing small about Little David. It was a mortar. The largest mortar ever built by any nation in history. Its bore was 914 millimeters, 36 inches. You could crawl inside the barrel. A grown man could sit inside the tube with room to spare. Each shell weighed over 1,700 kilograms, heavier than a Volkswagen Beetle. And it was built for one purpose: to blow open the fortifications of mainland Japan so that American soldiers could pour through the gaps. It was designed for the invasion that never happened. And because of that, Little David never fired a shot in anger. It remains one of the most powerful weapons ever created that was never used in combat. This is its story. To understand why the United States built a mortar the size of a building, you have to understand what American military planners were facing in 1944. The war in the Pacific was a nightmare. Every island the Americans invaded was defended by Japanese forces who had spent months, sometimes years, building fortifications. Bunkers made of reinforced concrete and coral, buried deep underground, connected by tunnels, and defended by soldiers who had been ordered to fight to the last man. Iwo Jima, Okinawa, Peleliu. Each of these battles cost thousands of American lives. The Japanese defenders would hide in their bunkers during the bombardment, then emerge when the Marines landed and fight with suicidal ferocity. Conventional artillery and naval gunfire could suppress these positions, but they could not destroy them. The bunkers were too deep. The concrete was too thick. The bombs and shells would explode on the surface, leaving the defenders underground shaken but alive. American generals looked ahead to the final battle. Operation Downfall, the invasion of the Japanese home islands. Intelligence estimates predicted that the Japanese had built thousands of fortified positions across Kyushu and Honshu. Concrete bunkers, cave networks, underground factories, artillery positions carved into mountainsides. The defenses would be far more extensive than anything encountered on the Pacific Islands. The estimated American casualties for Operation Downfall ranged from hundreds of thousands to over 1 million. It would be the bloodiest battle in human history. The generals needed something that could crack these fortifications open, something that could deliver an enormous explosive charge with enough force to penetrate deep underground bunkers, something bigger than anything that had ever been built before. The origin of Little David was surprisingly humble. It started life not as a weapon, but as a test device. At the Aberdeen Proving Ground, engineers needed a way to test aerial bombs. They wanted to launch bombs into the air so they could study their ballistic properties, the way they tumbled, their drag coefficients, their terminal velocity. To do this, they built a large-bore mortar that could lob bombs into the air, simulating a drop from an aircraft. This test mortar, known as the Bombard, had a bore of 914 millimeters, large enough to accommodate the biggest bombs in the American arsenal. It was never intended to be a weapon. It was a scientific instrument. But someone at Aberdeen looked at the enormous explosions these test rounds were creating and had an idea. What if we turned this thing into an actual weapon? What if we pointed it at the enemy? The concept was straightforward. Take the test mortar, mount it on a transportable platform, develop a purpose-built high-explosive shell, and ship it to the Pacific to blast Japanese fortifications into rubble. The Army approved the project in early 1944, and engineers at Aberdeen went to work. The challenges were enormous. First, the weapon itself weighed over 40 tons. The barrel alone was so heavy that it had to be transported on a special trailer. The base plate, the steel slab that absorbed the recoil when the weapon fired, weighed even more. Moving Little David required two specially designed transport vehicles and a crane to assemble it at the firing position. The weapon could not simply be driven to a location and fired. It had to be set up, a process that took hours. The base plate had to be buried in a pit dug into the ground, with the barrel lowered into position on top of it. Only then could it fire. The shell was a marvel of destructive engineering. Each round was 914 millimeters in diameter, packed with over 500 pounds of high explosive. When it detonated, the blast would obliterate everything within a large radius. The fragmentation pattern was devastating. Shrapnel would scythe through troops and light vehicles hundreds of meters from the impact point. But the real purpose was penetration. The shell was designed to punch into reinforced concrete and earth before detonating, collapsing bunkers and tunnels from within. In testing at Aberdeen, the results were spectacular. The craters were enormous. Concrete test structures were smashed apart. Simulated bunkers were obliterated. The weapon worked. It was slow. It was cumbersome. It was logistically demanding. But when it hit, nothing survived. The range of Little David was limited. The mortar could lob its shells to a maximum distance of roughly 8.5 kilometers, about 5.3 miles. This was not impressive by artillery standards. A standard 155mm howitzer could shoot twice that far. But Little David was not meant to engage targets at long range. It was a siege weapon, pure and simple. It was meant to be brought up close to a fortified position, assembled behind a ridge or inside a prepared position, and used to systematically demolish enemy fortifications one by one. In the planned invasion of Japan, it would have been positioned within range of specific defensive strongpoints and used to crack them open before the infantry advanced. The accuracy of the weapon was another challenge. Mortars are inherently less accurate than guns or howitzers because they fire at very high angles, lobbing shells into the air in a high arc. Small variations in propellant charge, wind, or barrel temperature can cause significant changes in where the shell lands. For a weapon with such a large and expensive shell, every miss was costly. The engineers at Aberdeen worked to improve the accuracy, and test firing showed that the weapon could consistently hit within a reasonable area. It was never going to be a precision weapon, but for its intended purpose, destroying large fortified areas, pinpoint accuracy was not necessary. If the shell landed within a few dozen meters of the target, the explosion would still do catastrophic damage. But then something happened that changed the course of history and rendered Little David obsolete overnight. On August 6, 1945, a B-29 bomber named Enola Gay dropped an atomic bomb on the city of Hiroshima. 3 days later, a second bomb was dropped on Nagasaki. On August 15th, Japan surrendered. Operation Downfall was canceled. The invasion of the Japanese home islands would never take place. The millions of soldiers, the thousands of ships, the mountains of equipment that had been prepared for the invasion were no longer needed. And Little David, the weapon that was supposed to crack open Japan's defenses, was no longer needed either. The timing was cruel. Little David was being prepared for shipment to the Pacific when the war ended. It was almost ready. The weapon had been tested. The shells had been produced. The transport vehicles had been built. Everything was in place for the weapon to be loaded onto a ship and sent to join the invasion fleet. But the atomic bombs made all of it irrelevant. In the blink of an eye, the most powerful conventional weapon ever built by the United States was made obsolete by something even more powerful. The age of nuclear weapons had begun, and weapons like Little David belonged to the past. After the war, there was some discussion about what to do with Little David. Some suggested using it for further testing. Others proposed adapting it for peacetime applications, though nobody could figure out what peacetime application a 900mm mortar might have. In the end, the weapon was simply retired. It was put on display at the Aberdeen Proving Ground, where it sits to this day. Visitors can walk up to it and look down the barrel. It is an astonishing sight. The bore is large enough to swallow a person whole. The shell, displayed next to the weapon, is taller than most adults. It is a monument to the desperation of total war, to the willingness of engineers to build something enormous and terrible in the hope that it might save lives by ending a battle more quickly. Little David occupies a strange place in military history. It was the largest mortar ever built, and it was never fired in combat. It was designed for a battle that never happened. It was made obsolete by a weapon that changed the nature of war itself. In some ways, it was the last of its kind. The final expression of a tradition that stretches back to the medieval bombards and siege cannons that battered castle walls. For centuries, armies had built bigger and bigger guns to break through fortifications. The great Turkish bombard at Constantinople, the mortars of Vauban, the railway guns of World War I, the German Gustav and Dora in World War II. Little David was the American entry in this ancient arms race, the biggest conventional siege weapon ever devised. And it was the last, because after Hiroshima, nobody needed siege weapons anymore. A single bomb could do what Little David required dozens of shells to accomplish. There is something melancholy about Little David. It was built to prevent American deaths in the most terrible battle that was ever planned. The engineers who designed it believed they were creating a weapon that would save the lives of hundreds of thousands of young men. In a way, the atomic bomb stole that purpose. Little David never got to prove itself. It never had the chance to justify its existence. It sits in a field in Maryland, slowly rusting, visited by tourists who take pictures and move on to the next exhibit. But for the engineers who built it, and for the soldiers who were preparing to invade Japan and who knew they would probably die on those beaches, Little David was more than a curiosity. It was hope. A desperate, monstrous, beautiful hope that something, anything, could make the coming slaughter a little less terrible. The story of Little David is ultimately a story about the absurdity of war, about the lengths to which human beings will go to destroy each other and to protect each other, about weapons that are built and never used, and about the strange mercy of a war that ended before the worst could happen. The next time you see a picture of Little David, with its absurdly wide barrel and its impossibly large shells, remember what it was for. Remember the invasion that never came. Remember the millions who were spared. And remember that sometimes, the most powerful weapons in history are the ones that never fire a shot.